In my last blog post, I covered PageRank, a graph algorithm used to determine the importance of nodes in a graph. Now in this video, we will expand on that algorithm to cover the personalized PageRank. Now first, I'll describe what is personalized PageRank, and then we will work through an implementation of this algorithm from scratch in a Jupyter notebook. Now, before we get started here, if you haven't read my original blog post, I recommend you go and work through that first. You can find a link to that blog post in the description below. Okay, so now we're in a Jupyter notebook, and this is what we'll be working through for the discussion to come. Just note that I've placed this notebook on my GitHub, and I've included a link to it in the description below, so you can find this notebook there and work through it yourself if you'd like. So first off, what is PageRank? So I went into quite a bit of detail on my blog post regarding what is the PageRank algorithm. Just to summarize it, PageRank is an algorithm that was originally developed at Google for the task of ranking web pages. So the idea is that you can model the internet as a graph where the nodes in the graph are the web pages and different links between the web pages are the edges in this graph. And the idea is that the more interconnected a web page is, so the more edges it has, the higher its ranking should be. That makes intuitive sense. And essentially that's what PageRank tries to do. Personalized PageRank adds a little bit more to it, in the sense that it tries to capture also personal preferences into the logic. So say, for instance, if I am interested particularly in, say, nature articles or nature websites, I have a higher chance of going to those websites as opposed to, say, baseball, which is something I'm not particularly interested in. The vanilla PageRank algorithm can't take that into account. It rates web pages solely based on how interconnected they are with the rest of the graph. The personalized PageRank is trying to look at things from a more individual perspective. And not only is it trying to emphasize specific web pages that, say, I've visited, but also the web pages that are highly connected with those web pages that I visited. So it also serves in a way as a recommendation engine as well. It can serve like that as well. So that's something very neat about this algorithm, and it has quite a lot of applications. So now we can begin with working through the notebook. So let's just first import the packages that are necessary. And now I'll run the notebook that I used for my blog post. And this is where I defined various different objects. I implemented a class to handle all the graph functionality, as well as the vanilla PageRank. So I'm going to run that notebook. It's in the same folder as this current notebook. But just keep in mind, if we hop over to that notebook, if you'd like to run this, you have to comment out the cells that fall under verify results at the bottom. So just make sure you do that before proceeding. So here we are back in our personalized PageRank, and I will run the notebook. It's done. So now we can take a look at the edges that we got from running the notebook. And so here you can see the various different edges in the graph. We can also visualize it. And here you can see our 6-node graph. So we can see that nodes A, B, C, and D are fairly well connected with each other. And then we have two edge cases as well, which is E, which is a sink or a dangling node. It has a single edge pointing from D to E. And then we also have F, which is a source node. So now let's work through, or at least go through some of the math behind the algorithm. So in the blog post, we saw this as our update rule. So in the blog post, I mentioned the update rule that we have here, where P subscript R are page ranks, and in parentheses is the iteration we're talking about. So T represents the iteration in the algorithm we're dealing with. So T is the current step, and then T plus 1 is the next step. And you can see that this update rule is governed by two terms on the right-hand side of the equation. So the first term, where we have D, which is our damping factor, multiplied by O hat, which is a modified adjacency matrix, times the page ranks. This essentially accounts for a user following the edges in the graph or following links on the web page. So that's what this first term is taking care of. And then the second term essentially describes our flyout probability. That is, it's the probability that a user does not end up on a web page or a node in the graph, does not end up there from following one of the links or the edges. Instead, they just decided to break from following the edges and just decided to go directly to another page. So that's what the second term is governing. You can see we have this column vector, which is composed of n subscript p elements. And n subscript p is just the number of nodes that we have in the graph. So to do personalized PageRank, all we have to do is change or set up how we're going to create this column vector. Normally, in vanilla PageRank, this column vector is composed of elements of 1, so they're all ones. And this represents the probability that from any node in our graph, it is possible to fly out and end up on another node in the graph. And that's all given equal probability. That's how the vanilla PageRank works. However, with personalized PageRank, what we want to do is manipulate this column vector to reflect our preferences. And in this sense, say if for example, my preference is to node D and only node D in this graph, then what I would do is construct one, this bold column vector 1, such that all its elements are 0 except for the element that represents node D, which I would set to be a 1. You can do that for either one node or multiple nodes, so long as it's a subset of the total nodes in the graph. And that exclusively is the change that we'll need to do here to implement personalized PageRank. That's it. So what we can do is implement that. And that's what I've done here in the next cell, this very short class definition, personalized PageRank. And here I inherit the PageRank that we got from my earlier notebook. And all I do is I include this additional input argument, selected nodes, and that reflects my preferences for the nodes I want to give more weight to. And then I overwrite the identity vector function. So that's this column vector 1. And now I construct it in the way I just described. So whatever nodes are in the selected nodes input, will now be assigned 1 and everything else will be 0. And that's how I set up the identity vector. So let's run this implementation, and now we can test it out. So let's create a graphs object. And graph is, again, it's something that I brought in from running the previous notebook. And now we can run the personalized PageRank, and here I have set selected nodes to be C and D, so just these two nodes, and let's see what we get. So if I take a peek at the ranks, here you can see the respective rankings. So you can see C and D have pretty reasonable rankings. You can also see node A gets a very heavy ranking as well, and that's just reflective of the fact that node A is highly connected with nodes C and D as well. So if we look at the identity vector, we can also verify that it's been constructed correctly. This is exactly what you'd expect. We can play around with this a little bit more. So if we try now to just look at, say, node A, we can rerun this. And here you can see the page rankings with respect to node A. So you can see, not too surprising that this node gets a very high ranking, but then you can see that the next highest node is C, followed by D. And yeah, we can just keep playing around with it. You can go with just D by itself and see what it gets. You can see that the ranking for D now jumped up. And C also has a very high ranking, and A as well. You can see that these three nodes are quite closely tied to each other. And if I take a peek at the identity vector, you can see that, again, it's been set up correctly. So yes, that's everything that I wanted to cover in this video. I hope this gives you some insight and intuition for how personalized PageRank works and what it's used for. So if you got some value from this video, please like the video and share it. If you like the channel, you like the content that I do, please subscribe. It's always appreciated. And if you have any comments or suggestions, please leave those in the comments section below. And until next time, I will see you in the next video.